Hi, I'm Chachik and I am back with another video. In this video, I will not tell you a formula of mathematics, but I will discuss with you all some mathematical theorems. I have nearly 150 mathematical theorems, but it is not easy to discuss all the 150 mathematical theorems in a single day. So I need a couple of days to discuss all the theorems. And I didn't know the explanation of all the theorems, but I am familiar with some of the theorems and I will try to discuss the theorems very clearly. So let's start. Number 1 is the irrationality of the square root of 2. This formula states that root 2 is an irrational number, and we have to prove that how root 2 is an irrational number. Basically, this type of theorems are proved negatively. If the question is given that prove that root 2 is an irrational number, then we will assume that let root 2 is a rational number. And if the question is given that prove that root 4 is a rational number, then we will assume that let root 4 is an irrational number. Okay. Then number 2 is fundamental theorem of algebra. Number 3 is the denumerability of the rational numbers. Number 4 is Pythagoras theorem. Pythagoras theorem. In a right angle triangle, there are 3 sides: perpendicular, base and hypotenuse. Hypotenuse is the longest side of the right angle triangle. If we will draw a square at the perpendicular at the side of perpendicular, and another square at the side of base, and another square at the side of hypotenuse, then the area of square at the side of hypotenuse is always equal to sum of area of square at the side of perpendicular and the area of square at the side of base. Okay. Then number 5 is prime number theorem. Number 6 is Gödel's incompleteness theorem. Number 7 is law of quadratic reciprocity. Number 8 is the impossibility of trisecting the angle and doubling the cube. Number 9 is the area of a circle. Number 10 is Euler's generalization of Fermat's little theorem. Number 11 is the infinitude of primes. Number 12 is the independence of the parallel postulate. Number 13 is polyhedron formula. Polyhedron formula is commonly known as Euler's formula. In a three-dimensional figure, let us consider the three-dimensional figure cube. In a cube, there is edges, vertices and faces. The polyhedron formula is V plus F minus E is equal to 2. That means number of faces plus number of vertices minus number of edges is always equal to 2. And this formula is suitable for every three-dimensional figure. Then number 14 is Euler's summation. Number 15 is fundamental theorem of integral calculus. Number 16 is insolvability of a general higher degree equation. Number 17 is de Moivre's theorem. Number 18 is Liouville's theorem and construction of transcendental numbers. Number 19 is Foursquare's theorem. Foursquare's theorem states that every natural number can be represented as the sum of 4 integer square. Every natural number can be represented as a sum of 4 integer square. Then number 20. Number 20 is all primes equal to sum of 2 squares. Number 21 is Green's theorem. Number 22 is the non-denumerability of the continuum. Number 23 is the formula for Pythagorean triples. Pythagorean triples. An example of Pythagorean triples is 3, 4, 5. Here in this triple, 5 is greater than 4 as well as greater than 3. So in a right angle triangle, 5 is the length of the hypotenuse, 3 is the length of perpendicular and 4 is the length of base. You can also take 4 is the length of perpendicular and 3 is the length of base. And 5 square is always equal to 3 square plus 4 square. This type of to find this type of Pythagorean triples, there is a formula is m square minus 1 m square plus 1. This formula is suitable to find more Pythagorean triples like this. 24. The undecidability of the continuum hypothesis. Number 25. Schrödinger-Bernstein theorem. Number 26. Leibniz series of pi. 27. Sum of the angles of the triangle. This is a very common theorem. In a triangle, there are 3 angles. If we will add all the interior angles of a triangle, then the answer will always come 360 degrees. This theorem is suitable for every triangle. Either it is scalene triangle, or isosceles triangle, or equilateral triangle, or it is right angle triangle. Then number 28. Number 28 is Pascal's hexagon theorem. Number 29 is Feuerbach's theorem. Number 30 is the Bellot problem. For today, this much. Thank you.